because if you look, I have negative 9y, and I have positive 3y. What can I multiply this 3y by to get a 9? A 3. Would I have to even multiply this by anything? No, it's already a negative 9y. So if I have a positive 9y and a negative 9y, I can add those. They're opposites to get 0. So let's do that. So make sure you have a pen or pencil. I am going to multiply this first linear equation, every term, right? There's 3 terms. Multiply all 3 by that positive 3. No! No! You don't need a calculator. You can do this, right? Can you do this? You can do this. Oh, you mean for the later problems? That's fine. Okay, I'm going to pause here. Does everyone see what I just did to that first linear equation? I distributed the 3 to all 3 of those terms. Now, if you take the second linear equation and just copy it, okay? So don't touch anything there.
Wait, why did you put a 3?
Okay, let me see if we can help Miriam understand why did I put a 3? Why did I choose 3 to multiply all 3 of those first ones by? Okay, that's probably like a couple of steps. The reason is I'm trying to get the same or opposite signs with the same number to my constants or to my coefficients. So Miriam, if you look here, this one is a negative 9y. This is a positive 3y. If I multiply that 3y by 3, then I get a positive 9y. And if you look, do you see how these are the same number, but the signs are the opposite? So if I use the operation addition now to add like straight down, then this is going to make 0y or nothing, right? So that would be elimination. All right, so that's your goal. Your goal is to get the numbers to be the same in front of one of your variables or to be opposites. If you can do that, then you can use one of the operations to get rid of it. So let me just, before we finish this problem, what if they both would have been positive 9y? What if they both would have been positive 9y? It wouldn't cancel with addition, right? Because 9y plus 9y is 18y. But what could I change this to be? I could make it subtraction, right? Because then if I did 9y minus 9y, that would be 0. So just be careful. I would recommend, if you can get them to be the opposite, it's easier because you can use addition. But it's not wrong if they are the same. Just make sure you use subtraction. Yes, that's a great thought, class. Make sure you're using the correct sign. Okay, so what is 12x plus negative 5x? What is 12x plus negative 5x? 7x. Now we know what's going to happen to my y's. They're going to make 0, right? I am eliminating it, right? That's the whole point of this. So equals, what's negative 15 plus 22? Positive 7, right? Remember they're opposite signs, so you subtract them, keep the sign of the bigger one. So x equals 1. What up, Miriam? What up? Now, if you stop here, you won't get full credit on my test, and you'll have to continue on Delta Math to get the y value as well. But once you get one of them, so in this case, you got x equals 1. Exactly. You got to plug in the 1 to x. And now here's where I would say, do I care which one you choose? Like, could you choose this one or could you choose this one? It doesn't matter. So which one would you like to choose? Sounds good. The bottom one. So you're choosing negative 5x minus 9y equals 22. What am I replacing x with? A positive 1. So I plug in uno, which gives me negative 5 minus 9y equals 22. How do I move that negative 5 to the other side? Add. Gosh, you guys are on fire this morning. I love it. Not literally. That would be scary. Negative 9y equals 27. So what is y equal to? What number times negative 9 gives you 27? Close, Natalia. No, you were closer when... It'd be negative 3. Nice, Samantha. Yes, because 9 times 3 is 27, but we need it to be a negative times a negative to get a positive. So do you remember from yesterday, for those of you that were here, what was my solution to my linear systems yesterday when we did graphing? Do you remember how we wrote the answer? It was an ordered pair, X and Y. What up? Oh my gosh, we're feeling it. So what's going to be my solution here? 1, -3. Now just be careful when you're doing this. I know we found X first, so that's why it goes there. It's X. But if I had found Y first, make sure you don't put the wrong order, right? It's always X, comma Y, right? Think of your alphabet, okay? I told you the joke that my son told me the other day about what does a bat learn in school first? The alphabet.
Oh, yeah.
Yeah. That was a good one. Or not. Okay. All right. Any questions on the first one? Remember, he's 8. Okay, so that's be nice.
He's the same age as Lonnie's brother.
Oh, yeah?
Yeah.
Nice. They could. So Emmanuel just said out loud right here, he just said if they were the same number, should we subtract? Yes. If your symbols are not opposites, right? These were opposites, so I added. But if they had both been positive 9y, I would have subtracted. Yeah. Okay, let's try this one. Now, I think we have a couple options here. We have a couple options for this first or for the second one. All right. I think some of you may want to eliminate the x because if this is 5x here and this is 1x, what could I multiply all 3 of the things in the top by to get the same number? What can I multiply this one by to get the same number as the one below it? 5. Very good, Gladys. Do you hear what Gladys said? She said 5, right? Because what's 5 times x? 5x. And then they would be the same, Emmanuel. So what operation would I choose if I did that? I would subtract, right? So I'm going to do that in a moment. But someone else might do something to this one. What could someone do to the second one to also eliminate one of the variables? No, I don't want to multiply by a number. I heard Samantha say by 2. Why'd you pick 2, Samantha? And then I'd have 2y here, same as 2y up there, and then I would use subtraction. Are either of those going to give you the right answer? Yes, both of them will, as long as you do the math correctly. Do I care which one you decide? I do not, right? So whichever one you're kind of drawn to, you can do that. Personally, I think they're both going to be the same level of difficulty, but it's up to you. I'm going to do the one you said, Gladys, just because I want to show you what happens when we use subtraction and when we eliminate the other variable, right? And number 1, we eliminated y. With this strategy, Gladys, we're going to eliminate the x. Okay, so what is 5 times x? 5x. What's 5 times 2y? Nice, Hector. And then what's 5 times 0? 0. All right. Am I doing anything to the second equation? No. So I'm just going to copy that down. All right. Now, again, different from what we did in number 1. If you look at the signs in front of those 5s, they are the same, right? They're both 5x. So what operation am I going to do? Now, if I do addition, I'm going to do 5x plus 5x, which would be 10x, right? I'm trying to get 0x. So I think I heard Luke say it. We want to use subtraction, right? Because 5x minus 5x would be nothing. Okay? So just be careful. That whole thing you said earlier, Gladys, of choose the right sign, just make sure you're eliminating. And you'll know, Gladys, right? Because if you choose addition and you do the math, you'll be like, wait, nothing made 0, right? So you'll notice, like, oh, I made a mistake. Okay, so 5x minus 5x is gone, right? That's 0. Now, what is 10y minus 1y? 9y. Now, this can be a little tricky here. Be careful. What's 0 minus 45? Nice. Negative 45. Good, Gladys. All right. Now, do you know what value times 9 would give you negative 45? Negative 5. What up, Donovan? Yeah. Good job. All right, we're halfway there. At this point, we're going to plug it in. Hector, can you choose one for us? Do you want to choose the first or the second one? It doesn't matter. First one. So Hector's choosing x plus 2y equals 0. I'm going to replace y with negative 5. And that gives me a negative 10. How do I move that negative 10 to the other side? How do I move that negative 10 to the other side? Add 10. Thank you, Samantha. So then x is going to be equal to 10. All right, now be careful when you write your solution. Remember, the ordered pair is always x comma y. So what's going to be my ordered pair? Good. So even though we found the negative 5 first, notice we're writing that still in the correct spot, which is this thing, because this is y. I don't want you to get tripped up, right? Some students will put negative 5 comma 10 and be like, that's not x comma y. All right?